right. Um, Welcome back, everyone. And as we promised, today we talk about the third video in which we discuss the reason why we still might want to go forward with the Euclidean type of simulation, geostatistical simulation, uh, when we process the altimetry data in Greenland. Remember, we were talking about this. We've been talking about this, I think, for 2 days now. We started talking about Antarctica and the reason why we might need to switch to geostatistical simulation in the sphere for Antarctica because of the reason because of the geometrical reason, right? And last time we also talked about the special case where if you reduce the domain in which you're working, for example, when we do time series modeling, we're not producing one time series for the entire ice sheet, right? We have like one location or like a little box in which we're working. So in that case, like when you're working on a small region, very small compared to the size of the ice sheet, you can decide to, you know, you can decide not to use uh, just statistical simulations in the sphere. You can still use the Euclidean way of doing. Today, we will see why it is not the same scenario, or it's not the same situation when we talk about Greenland. And what I will do to show you what exactly I'm talking about today is I will just take you to my Google Explorer and show you. Last time when I was talking about Antarctica, I will show you what I was talking about, and today we'll see why in Greenland the situation might be different. All right, so here we are in my Explorer. So what we will do now is I will just show you something real quick. If you zoom in, you can see those lines, right? And when you're over here, for example, this shape looks more like a square. At least to me, it looks like a square. It's not a real square. I mean, it's a little bit. It's not really a square, but I can transform it into a square easily because at least the shape is close enough to a square. But look at this one. Like, let me zoom out so that you can see. Look at this one. Compare the shape of this one to the shape of this one. And don't tell me it's because of the way we are looking at it. Because if you go this way, then I'm looking at it the same way I was looking at uh, the other shapes, right? But I mean, when you get closer and closer to this point, you don't really have those square kind of shape, right? Like it's really going from a square to a triangle. That's why when you get closer to this point, using UTM projection, reprojections uh, gets harder and harder. It's really difficult because of the way you have these lines crossing each other, and so the reprojection gets harder and harder as you move closer to this point. So this is the North Pole. So let's go down to the other one that we were trying to look at the other day. And here it is. This is Antarctica. So you see, Antarctica is just right into that region that we was talking about the other day. It's right into it. It's really like the entire, and this point is on the ice sheet. This point is on the ice sheet. Actually, this is a big challenge because most of the missions that were developed in the past, I would say prior to 2000, they couldn't really get a measurement in this point, like on this point. And I think as we move from the old missions to the recent missions, the circle in which you don't have data is diminishing, like it's decreasing. The area of that zone is decreasing still. you have some locations around this point where you don't have data. It's a big challenge. It's one that I'm targeting, like one that I'm working on, trying to kind of, address it. Not in the sense of having a new satellite going there to measure the data, but finding the strongest way possible to fill in that spot. Okay. Anyway, we talked about Antarctica last time today. And so look again, you see Antarctica, the reason why, because they are all like yeah, it was it's 90, 80, 70, really in this region where you have Antarctica, but it's really like the South Pole, right? So let's go back to the North Pole and let's try to locate Greenland. Boom. See? Let me zoom in so you can see. This is Greenland. So if you zoom in, you see, for example, over here, we still have this kind of square. It's not really a square, but it is kind of the major point that we can take out of the bucket here is it's not the air sheet is not in this region where you have those meridians crossing each other. It's not really in that region. It's somewhere below. It's not also too far from it to say that, oh, UTM projection will work so well, so fine. It's going to be perfect. And as a matter of fact, you can have different GIS dataset from Greenland. Be very careful about the reprojections. Sometimes people are using 32, 60, 32, 624. I think that is UTM Node 24. And there is another one that is corresponding, I think, to UTM Node 22. I mean, the zone, but the zone N22 and N24. So, anyway, you can have at least, I think, those two projections. So, be very careful when you process the data provided to you and coming from Greenland, because if someone is reprojecting those data, you have to know what the reprojection so that you don't do any mistakes. Sometimes it's not big because sometimes it's just that you process the data and have the result. And when you want to compare to something else, it's shifted a little bit. You can always do the reprojection or do the back reprojection. I don't know how to say that. You can always kind of play between those two. But anyway, you see why here it might be easier compared to when you do it in Antarctica, right? Because it's really we are really not crossing this line too much. See that line, the 18 or we are not really crossing. We're not really going over it too much. It's like a little bit of the ice sheet is going over that line, but most of them are below. So most of them are in the region where I have four corners instead of three, which is why for Greenland it does work at least better than in Antarctica because most of it is below. And I think actually for Greenland, when you do the reprojection, even this part is shifted so that the entire thing is kind of below this line. I can't tell you if that was the reason or not. This one right here is just something I just noticed because whenever I'm working with the data, the shape is a little bit tilted on this side. Well, tilted, no, just rotated. It's like this. And so I'm just thinking if you do that rotation and you maintain these lines intact, it's going to be a little bit below that line. So, yeah. Anyway, so that's why for Greenland, it might be easier just to, use a reprojection because it does work. Use a reprojection and do your job. And yeah, that's all I wanted to say about the impact of geometry on simulations for large datasets. And what we will do next in the coming series is we will take some example from different authors, kind of going into those examples and hopefully
show you how you can implement those algorithms in your own situation or in your own project onto the
see
yeah.